Let's say you are trying to evaluate a limit, but as you directly substitute, you get 0 over 0. You try another limit and you get infinity over infinity. So what is the solution to these limits? Is it 1, 0, is it unbounded, or maybe the limit just doesn't exist or is indeterminate? The answer? None of above. Remember that when you run into indeterminate forms after direct substitution, you can find some of the limits if you use a bit of manipulation, such as factoring, rationalization, or trigonometric identities. But some limits are a bit harder to solve, so let's add another tool to your limit solving toolbox, L'Hopital's rule. L'Hopital's rule is a simple but magical rule. It states that if you directly substitute into a limit and run into an indeterminate form like 0 over 0 or infinity over infinity, you can take the derivatives of the top and bottom and then take the limit of the new fraction. Of course, in order for this to work, the derivatives must exist, and the derivative of the denominator cannot be 0, otherwise you get division by 0 and that's not good. In this example, directly substituting in 0, we get sine of 0 over 0, and sine of 0 is 0. So we've run into an indeterminate form, 0 over 0. Now, this limit can't be manipulated very easily algebraically, so let's use L'Hopital's rule. For clarity's sake, let's call the top function, sine of x, f of x, and let's call the bottom function, x, the function g of x. The derivative of the numerator, or sine of x, is cosine of x, and the derivative of the denominator, or x, is 1. Both derivatives exist. According to L'Hopital's rule, now we take the limit of cosine of x over 1, or just cosine of x. Directly substituting in 0, we get cosine of 0, or 1, which is the limit. So, now you know what L'Hopital's rule is, but why does it even work? Let's try to build some intuition. The derivative of a function at point A represents the slope of the tangent line there. For x values near A, the equation of the tangent line serves as a linear approximation for the function. The closer the values are to A, the more accurate the approximation, and we can figure out the tangent line's equation. We know the derivative is the slope of the tangent line that touches the function when x equals A and y equals f of A. So the linear approximation of the function is the equation of the tangent line. Now, here's where all the magic happens. Let's say we're taking a limit of f of x over g of x as x approaches a. Now, f of a and g of a are both 0, so if we directly substitute, we get an indeterminate form, 0 over 0. Okay, but we also have our linear approximation. So, in these problems where f of a equals 0 and g of a equals 0, this approximation simplifies to this. So, what would f of x over g of x become? Well, the x minus a cancels out, and you're left comparing the slopes. But wait, the slopes are just the derivatives. And that's very similar to what we have in L'Hopital's rule. The only difference is that the derivatives are functions. Now, what I just showed you is not a formal proof of L'Hopital's rule, but hopefully it gives you some idea of why it works. Alright, now let's try a limit together and see if we can use L'Hopital's rule. What is this limit? Well, as x grows larger and larger, the natural log of x grows slowly, but x grows really fast. However, both still approach infinity, and infinity over infinity is indeterminate. So let's use L'Hopital's rule and take the derivatives. The derivative of the natural log of x is 1 over x, and the derivative of x is just 1. So according to L'Hopital's rule, we're taking the limit as x approaches infinity of 1 over x over 1, or just 1 over x. Now, if we directly substitute, we get 1 over infinity. Now, as the denominator gets larger and larger, 1 over x is going to get smaller and smaller. So as x approaches infinity, the limit approaches 0, and that's the limit using L'Hopital's rule. The limit is 0. L'Hopital's rule is one of the cleanest ideas in calculus, and it's super straightforward. So next time you're stumped on a limit with an indeterminate form, try using L'Hopital's rule. It just might turn confusion into clarity. If this video helped you out, if you enjoyed this or found something useful, consider liking the video, subscribing, and sharing it with friends. Now, keep working hard and keep learning. Thank you for watching.